Welcome back to the Simulator Series. In today's episode, we are going to be scripting the pet index system. Now, as always, if you guys do enjoy the video or it does help you out, make sure you smash the like button, also hit the subscribe button, and turn those post notifications on so you get notified every time I upload a brand new Roblox development video. Additionally, I have a Patreon if you guys like to support me and you can access all the scripts and the game file that I make during this episode. There's a link down below in the description, and you guys can go and check that out. With that being said, let's hop right into it. So, hopping directly into Studio, the first thing that we're going to do is actually add the player data. Of course, to do this, we're going to go inside of the replicated storage, open up the player data folder, and open up the template module script. Inside of here, we currently have a variable called egg_config. What we're going to do is copy and paste this, and this time we actually want to create the variable for the pets config. So we're going to say configs.pets, and then we're going to say pet config. Now, you may see a red underline just as I am under the require statement, and if we hover over this, we can see the error message actually says cyclic module dependency, and then it shows game.replicatedStorage.configs.pets, and then it has an arrow pointing to game.replicatedStorage.playerData.template. So what this means is that the template module script is requiring the pets module script, but also the pets module script is also requiring the template module script as well. So it's basically creating a require circle. So what we want to do is go inside of the configs folder, open up the pets module script, and then we actually want to delete this variable right here and no longer require that template module script. Now that we've removed that variable from the script, we also have to update some of the things down below here. The only reason that we were actually requiring that module script was so that we could use the player data type. And unfortunately, because both module scripts are not able to require each other, we have to actually remove these types. Now, removing these types isn't really a big deal at all. The thing that's nice about setting the specific type is that when we're actually using that variable, we could say something like data dot, and then because we said the specific type of the variable, we would then see a couple of other options besides pets that we could index inside of that table. But that's not necessary at all, and it's just a small little helpful thing. So let's go ahead and make sure that we delete this type from all of the functions and variables that actually use it, and now we're good to go. Going back inside of the template module script, you still might see this red underline, even though we did just update it. I think if you delete the variable and then recreate it, that should get rid of that red underline, and you should be good to go. After that, what we're going to do is copy the default reburst button and the for loop directly under it, and then we're going to paste it. Then what we're going to do is rename this variable. So instead of being called default rebirth buttons, we're actually going to call this default pets underscore collected, and that's still going to be equal to a table. Now for the for loop, we actually want to loop through the pet config.config, and in our for loop, the key is actually going to be the pet, and the value is still going to be info, so we can leave that. Then what we want to do is copy this variable, so default pets collected, and update the default reburst buttons with the variable we actually want to use. And instead of indexing this with rebirth, we actually want to index this with the specific pet. Then we want to actually set this equal to false. Now the reason that we're doing this is because the entire point of the pet index system is to basically track all the pets that the player has actually collected. And by default, they of course should have no pets collected, and we should only update those values whenever a player receives a brand new pet. So that's why we're looping through all the pets into our game, adding them to this table, and setting the value to false. Now that we've done that, what we can do is go down to our template variable right here, add a comma after we set the auto delete pets variable, and then we're going to say pet index, and then we're going to set that equal to default pets collected, just like that. Now we're done with adding the player data. The next thing we want to do is actually go into the pets config and add a few more functions to this. So inside of the pets config, towards the bottom of the script, we're actually going to copy the get total stored pets function, and then we're going to paste it below the get maxed equip pets function. We're then going to rename this function. Instead of saying get total stored pets, we're going to say get total collected pets. Then what I'm going to do is make a new for loop, and we're actually going to be looping through the player's pet index data. So the key of this is going to be the pet, and the value of this is going to be if it is owned or not, and that's going to be inside of data.petIndex. Now if owned is set to true for that specific pet, then we just want to add 1 to the amount variable. And then finally, once the loop is finished, we're going to return that amount variable as well. Now additionally, we're going to make another function, but we're going to copy and paste that get total collected pets function, and we're going to rename this function to get total pets. And we're actually going to delete the argument right here. Now for this for loop, since we no longer have a data variable, what we're actually going to be looping through is the config variable, so the config table. And now the key is still going to be pet, but the value is actually going to be info. And every time we go through this loop, we just want to add 1 to the amount variable, and once the loop is done, we're going to return that variable. Now this function is for literally tracking the total amount of pets that are in our game. If you're confused at all by where we might use this function, there's different scenarios on both the server and the client where we would want to compare how many pets the player has actually collected versus how many pets there are actually in the game. So that's why we created both these functions inside of the pets config, so both the server and the client can share them. Now we're pretty much done with the pets config. What we can then start doing is working on scripting the GUI. So what we're going to do is go inside of the starter player, inside of the starter player scripts, inside of the GUI folder, and we're going to add a brand new local script to this, and we're going to rename this to pet index. Now inside of here, we are of course going to need to make most of our basic variables, so I'm going to copy and paste them right here. If you want to, you could go to most of our other GUI scripts and then just copy and paste most of them directly inside of this script. The primary ones that we need are the player service, the replicated storage service, and the starter GUI service. We also need a variable for the player and the player GUI, as well as also a remotes variable, which is inside of the replicated storage, .remotes folder, and then a pets folder inside of the remotes folder. And then we have a couple of modules. So we have the eggs and the pets config, as well as the viewport model, state manager, and format number module as well. And then below that, we have a variable called GUI, and we're setting that equal to the pet index GUI that we created inside of there. After that, we're going to create a variable called surface GUI, and we're actually going to set that equal to GUI.template. Now below this, we can create another variable called frame, and that's actually going to be equal to GUI.frame. Below that, we can create a variable for the container, so that's going to be equal to frame.container. And then below that, we can create a variable for the extra frame as well, and that's going to be equal to frame.extra. Now, apart from those frames, we also have a few other variables that we want to create. So we want to create a variable called progress bar, and that's inside of the extra frame. So we're going to say extra.progressbar. And then we also want to create a variable called total, and that's going to be equal to frame.total, and that's a text label. And then finally, we want to create a variable called exit, and of course, that's going to be equal to frame.exit because that's the exit button. Okay, now that we've created all of our basic variables, let's get started by just simply scripting the exit button. And of course, how do we always do this? Well, we say exit.mouse button one click, we connect that to an anonymous function, and what are we going to do? Well, we're going to set the enabled property of the GUI to false. Now that we've gotten that out of the way, we can start scripting all of the pet index models in our game. And what I mean by this is we want to begin displaying all of the surface GUIs on each of the pet index models. So we're going to start off by creating a local function. This is going to be called generate models. And inside of here, we're going to create a variable called models, and that's going to be equal to a table. After that, we want to loop through all of the descendants in the workspace. So we're going to say for_desk, which is short for descendant, in workspace get descendants. Do. Now, as we're looping through all the descendants inside of the workspace, we actually want to check the name of the workspace, and we want to see if the name of that is actually equal to pet index. Now, this is something that's really important. You need to make sure that all the pet indexes that you spread throughout the workspace in your game are actually named whatever you set as this specific string. So, for example, if there's not a space between the word pet and index, then you shouldn't include a space here. But based on how ours are set up, our pet index models are named pet space index. So that's why we have the string set up as that. So if we do find those specific models, then what we're going to do is we're going to insert that model into the models table. So we're going to say table.insert, and we want to insert the descendant into that models table, just like that. Now, after we create a table of all the pet index models in our game, we then want to loop through that table. So we're going to say for_model, and we're going to cast this as a model type in models do. Now, as we're looping through each of these models, what we're first going to do is set up listening for whenever a player touches the hitbox so that we can open up the GUI. So what we're going to do is we're going to say model.primaryPart.touched. And then we're going to connect that to an anonymous function, which is going to accept an argument called other part. Now, you might see a red underline here. You can completely ignore this. The reason that there's a red underline here is because since we're casting this variable to a type called model, not all models have a primary part. So this primary part might not actually exist on the model. And the reason for that is because the model is just a generic model type. It doesn't know the very specific model that we're talking about. So considering this is just a generic model, it doesn't know that all the models that we're looping through actually have the primary part set up. That's why we see this red underline. So you can actually ignore this red underline as it won't cause any issues in your game. Now, while we're listening to this touch event, we're going to create a variable called character, and that's going to be equal to otherPart.parent. Now, we then want to check if the character variable that we just created is equal to the player.character. And if it is, then we want to set the enabled property of the GUI to true. So the reason that we're doing this is because, of course, any other player could actually touch the hitbox part. And if any other player does touch it, we don't want to actually do anything. We only want to do something if our player's character actually touches that part, and then we want to enable the GUI. So now that we're listening and actually displaying the GUI for the players, what we then need to do is actually set up the service GUI on all these models as well. So we're going to create a variable called clone, and that's going to be equal to service GUI, and we're going to clone that. Then we want to set the parent of this to our screen GUI. Additionally, we want to set the adorning property equal to the model.display, because there's a part inside of our model called display, and that's where we wanted to display the service GUI on. Once again, you can ignore this red underline. The only reason that we're getting this underline is because the type of this variable is a generic model, and generic models don't have any parts inside of them, and especially not any parts called display. So that's why there's a red underline here, but once again, you can ignore this because it's not going to actually cause any errors in your game. After that, we're going to make sure that we enable the surface GUI, and now that we've basically created a fresh surface GUI, what we then need to do is actually generate the pet model to display that in the viewport frame. Now, before we do that though, we're actually going to create a new function. This function is going to be called getHiddenPetModel, and that's going to accept the pet, which is a string. Now, what we're going to be using this function for is to basically generate an all blacked out version of our pet. So for example, inside of a pet index, before a player actually collects a pet, we want to just display a blacked out version of that pet, so the player doesn't really know what it all looks like, and it's kind of a mystery, but you still see the general outline or the general structure of what the pet actually looks like. So inside of this function, we're going to create a variable called model, and that's going to be equal to replicatestorage.pets, and then we want to index that folder with the specific pet name. And once we get the pet, then we want to clone it. After that, we're actually going to loop through all of the descendants inside of this model. So we're going to say model get descendants do. Now, as we're looping through all of the descendants, we want to actually check if the descendant is a base part. And if it is a base part, then we're going to modify the color of it. And we're going to set that equal to a color3.new, and then we're going to make it all black. So now we're setting the color of all the parts inside of the pet to a black. And another thing that we want to do is we want to actually check if the descendant is a decal. The reason for this is because decals are usually used for faces on the pets. And if there's a decal inside of there, then we actually just want to destroy it. So we're basically removing the pet's face and setting the color of all the parts inside of it to black, and that gives us our hidden pet model. Finally, after the for loop, we're going to go ahead and return the pet model. Then we want to go back to our generate models function, right below where we did all the stuff for our surface GUI. Inside of here, we're going to create a variable called model, and that's going to be equal to get hidden pet model, and we're just going to pass through dog. You can actually pass through any of the pets that you want. This is just to display one random pet for the service GUI. So after we get that model, we're then going to use the viewport model module, and we're going to generate viewport frame. Then we're going to pass through clone.frame.viewport frame, and we're going to pass through the specific model, and then we need to pass through cframe.angles 0, math.rad -90 0 once again, so that the pet is facing the correct way. And now our viewport frame has been generated. So now we've set up the viewport frame on the surface GUI. We also have a couple of text labels that we want to set up as well. Now these text labels are dynamic, so what I mean by that is we're going to be modifying them in other ways as well. So rather than putting all of that logic specifically inside of this function, what we're going to do is actually create a brand new function for that. So we're going to create a function called update surface GUI. That's going to accept no arguments. And then what we want to do is loop through all of the children in our screen GUI. So we're going to say GUI get children do. And now if the GUI is a service GUI, then we know that we're working with our pet index service GUIs. So now we can actually update all the text labels. So we're going to create a variable called collected pets, and that's going to be equal to petsconfig.get total collected pets, and we're going to pass through the state manager.get data. Now we want to also create a variable underneath of this called total pets, and that's going to be equal to petsconfig.get total pets. Now that we've got both of those, we can actually update our text labels. So we're going to say GUI.frame, and inside of the frame we have a text label called progress, and we want to set the text of that. Now how we're going to set the text of that is by using the collected pets variable, and then after that we're going to say slash, and then we're going to display the total pets variable right after that as well. So for instance, if the player has 0 out of 10 pets, that's how it would be displayed right here. Then what we could do is copy and paste this. Inside of the frame there's actually a text label called %, so we want to update that right there. And how we're actually going to set this variable is by using math.floor, and then we're going to divide the amount of collected pets by the total pets in our game. And after we divide them, we want to multiply that number by 100 and then use math.floor on that. And after we do all that math and calculate that number, we're then going to add a % symbol to that to display something like 50% instead of just saying 50. Now if you guys are unsure why we're multiplying this specific number by 100, we can actually use our command bar right down below, and we can say print, and let's say we have something like 2 pets collected, and then we're going to divide that number by something like 10. And 10 in this case would be the total amount of pets in our game. So when we divide 2 by 10, we actually get a number of 0.2. And obviously to your players in your game, if they want to know the percentage of how many pets they actually have collected, they don't want to know that they have 0.2% collected. They want to know that they actually have 20% of the pets collected. So that's why we're doing our division first, and then we're going to multiply that number by 100. Now if you're wondering about math floor, the reason that we're using that is to prevent decimals from getting super long. So for instance, if we do 2 divided by 11 and multiply that by 100, that comes out to a pretty long number, and that can look quite ugly on a text label. If instead of doing that, we actually use math.floor on that specific number, we can see instead of getting 18 and then a long decimal after that, we just get a whole number, which is 18. So that's why we're doing the math that we're doing, and that's why we're using math.floor to make that number look pretty. Now a quick optimization that I actually just thought of is you don't actually have to create these variables inside of this for loop. You can actually just move them outside of your for loop and then just update the text labels inside of the for loop, and that works perfectly. Realistically, if you kept them inside of the for loop and they kept getting called over and over and over again, you will have no visible performance impacts, but we still might as well do it the optimized way because I think it's a great learning lesson for you guys. Okay, so now we're pretty much done with actually creating this function, and since we're done with that, we can actually call this function. And when do we want to call the function? Well, after the for loop finishes, when we create all the service GUIs, that's when we're going to call the update service GUI function, and it's going to update all the pet index service GUIs in the game. And now that we've done that, we've pretty much finished creating the generate models function, so we can go ahead and actually call that right after we create it. Now before we get into actually scripting the screen GUI, we actually need to add some functions to our eggs config. So we want to go, of course, inside of replicate storage, inside of the configs folder, and open up the eggs module script. Inside of here, we're going to go down towards the bottom of our script, and we're going to create a brand new function. This function is going to be called get total pets in egg, and this is going to accept an egg, which is going to be a string. Inside of here, we're going to create a variable called amount, that's going to be equal to 0, and then we want to create a variable called config, and that's going to be equal to eggs.getConfig, and we want to pass through the specific egg. After we do that, we're actually going to loop through that egg, so we're going to say pet for the key and pet info for the value in config.pets do, and then we're going to add 1 to the amount variable, and then at the end, we're finally going to return that variable. So pretty much what we're doing is we're going to grab one of these eggs, we're going to use the pets table, and we're going to loop through this table, and then each time we loop through it and we go through a new pet, we're just going to add +1 to that variable. Then we can actually copy and paste this function, and we're going to rename this function to get total collected pets in egg. We're still going to accept the egg argument, but we're also going to accept a data argument as well, which is actually going to be the player's data. Once again, we're going to do the same for loop. This time though, we actually want to go inside of our data table, and inside of here we have the pet index table, and we want to index the pet index table with the specific pet name. So if we do find that pet inside of the pet index and that is set to true, then we want to add +1 to the amount variable, and after the for loop ends, we finally want to return the amount variable. Then finally, we're going to create one more function. This is going to be called getEggOfPet, and it's going to accept a pet, which is a string. Then what we want to do is loop through the eggs config. So we're going to say egg info in config do, and then we're going to check info.pets, and we want to index that with the specific pet. Now, if we do find the pet inside of the eggs pets table, then we want to return that specific egg, and that's how we're able to find what egg the pet is actually inside of. Now, there's two more things that we actually have to do inside of this module script. The way that our pet index and how our egg system and pet system and everything else like that is going to be set up is that each pet should actually only be inside of one egg. And how the pets are going to be set up in our game is that each pet should only be available from one single egg. So currently, if we look at our config table, we can actually see some of our eggs share the same exact pets, and that's mostly just because we copy and pasted the same exact table multiple times over. So what we want to do is reorganize our eggs. So for the basic egg, I only have a dog and a bunny inside of here. For the earth egg, I have a fox and a pig. For the Arctic egg, I just have a turtle, and for the volcano egg, I just have a cat. So all of the pets are unique in each of the individual eggs, and none of them are in multiple eggs. I get that some people might not want their pet system set up like this, but this does seem to be how Clicking Simulator is actually set up, so I do apologize if you guys wanted it differently. There's hundreds of different ways to configure and set up a pet system, but at least you guys can still learn from this. So after we reset up all the pets tables in all of the eggs, we also want to create a variable right above our config variable, and that's actually going to be called eggs, and that's going to be a table. Now inside of this table, we just want to make a basic array of all of the eggs in our game, and we want to list these eggs in a very specific order. The reason that we're doing this is because how pet indexes are normally set up is the eggs that are displayed at the top of the container are actually the first eggs that the player is meant to come by. So for example, in our game, most likely how we want the flow of players to open up eggs, we first want them to access the basic egg, then we want them to access the earth egg, then the Arctic, and then move their way up to the volcano egg. The thing is though, is that because we use a dictionary for this, when we actually loop through the dictionary, there is no way to get orders of these specific keys. So when you loop through the config table, basic will not actually always be first. The first time we loop through it, it could either be basic, earth, Arctic, or volcano. There is no set order. So that's why we're creating an array of all of the eggs in our game, and the order is going to be very specific here because that's the order that the eggs will be displayed in the pet index GUI. So for the first egg, we're going to say basic. For the second egg, we're going to say earth. For the third egg, we're going to say Arctic. And for the final egg, we're going to say volcano. And now we have all of our eggs listed out in this array. So now that we've added all this to the eggs config, we can actually start generating the GUI. And to do that, we're going to go back to the pet index local script. So right above where we call the generate models function, we're going to create a brand new function called generate GUI. And to start this off, the first thing that we're going to do is loop through all of the eggs inside of the eggs config. So we're going to say for egg, comma, egg info in eggs config, .config do. Now as we're looping through all these eggs, we're going to create a variable called clone, and that's going to be equal to container.template, and we want to clone that template. Once we do that, we then want to set the name of our clone to the specific egg, and we also want to make sure that we parent that to the container. Additionally, we want to make sure that we set the visibility of this equal to true. And now remember how I just displayed to you about using that specific array to adjust which eggs are displayed in what order of the GUI? That's what we're going to do now. So we're going to say clone.layoutOrder equals table.find, and we want to look through the eggs config.eggs for the specific egg. And that's how we're going to set the layout order. Now, after we've done that, we can then generate the viewport frame. So we're going to say viewport model.generate viewport frame. And the viewport frame that we want to generate is actually the egg viewport frame. And what model do we want to use? Well, we actually want to use the egg model, which is inside of a replicated storage. Now that we've generated that viewport model, we actually want to loop through all the pets inside of this egg. So we're going to say for pet, comma, pet info in egg info.pets do. Then we want to create a variable called pet clone, and that's going to be equal to clone.template, and then we want to clone that template. Once we've cloned that, we can then go ahead and set the parent of that, and we're going to parent that to the clone. Then we want to set the name of this as well, and that's going to be equal to the pet. We then want to make sure that we set the visibility of this equal to true, and then we're going to set the layout order of this. And how we're going to set the layout order of this is based off the chance. We want to display the most common pets on the left side and the most rare pets all the way to the right. And how we're going to do this is pretty simple. We're just going to say minus petinfo.chance. So for example, if the pet has a 20% chance of hatching, then this would actually turn out to be negative 20. And then if another pet in the same egg has, say, a 5% chance of hatching, then the layout order would be set to negative 5. And of course, negative 10 is less than negative 5, so the negative 10 pet would be displayed on the left of the negative 5 pet, and that's how we're setting up the order. Now after that, we actually have a text label inside of the clone called rarity, and we want to set the text to that. And what do we want to set the text to that to? Well, just the petinfo.rarity. Now, similar to how we created the update service GUI function up here, we're going to do the same thing for some of the components of this GUI. So what we're going to do is create a brand new function called update egg. And what this is going to do is accept a specific egg as a string. Inside of this function, we want to get the viewport frame. So we're going to say local viewport frame, and that's going to be equal to the container. And inside of the container, we want to index that with the specific egg. And once we index that with the specific egg, then we want to get the viewport frame called egg. Now that we've gotten that viewport frame, we need to calculate the total amount of pets in the egg and also the collected pets in the egg as well. So we're going to say local total pets in egg, and we're going to set that equal to eggsconfig.get total pets in egg, and we want to pass through that egg. And then we want to create a variable called collected pets in egg, and that's going to be equal to eggsconfig.get total collected pets in egg, and we want to pass through the egg as well as the state manager.get data. Now that we've done that, inside of the viewport frame, there's actually a text label called total, and we want to update the text of that. And how we're going to set the text of that, we're first going to use the collected pets in egg number, then we're going to say slash, and then we want to display the total pets in egg number after that. So now we've just updated the total text label inside of our viewport frame right here. What we can then do is above this function, we can actually create a new function called update pet. That's going to accept an egg as the first argument and a pet as the second argument, both of these being strings. And we do want to get the viewport frame the exact same way that we did before, so we're going to create that same exact variable. This time though, we actually want to check if the pet is unlocked. So we're going to say is unlocked, and that's going to be equal to state manager.getData.pet index, and then we want to index that with the specific pet. Then inside of the viewport frame, there's a locked text label, and we want to set the visibility based on if the pet is unlocked or not. Now, if the pet is not unlocked, then we actually want to set the visibility of the locked text label to true. After that, we're going to create a variable called model, and for this variable, we have two different models that we might want to get. So if the pet is unlocked, then we want to just grab that pet model from inside of the replicated storage inside of the pets folder. If the pet is not unlocked, then we want to use the get hidden pet model function to actually generate that model. So if not is unlocked, then get hidden pet model, pass through the pet. But if the pet is unlocked, then inside of the replicated storage, inside of the pets folder, we're going to index that with the specific pet, and then we want to clone that model. Now that we've gotten the model, we can use the viewport model module, generate viewport frame, pass through the viewport frame, pass through the model, and then we want to use our normal cframe.angles, so we're just going to copy and paste it just like that. Now, since we are updating the viewport frame, we want to make sure that there are no other models in the frame before we add another model to this, otherwise we can have a memory leak. So what are we going to do? We're going to say viewport model.clean viewport, and then we're going to pass through the viewport frame just like that, right before we generate the viewport frame once again. So going back to our generate GUI function inside of this for loop, after we set the text of the rarity text label, we can then actually call the update egg function, pass through the egg, and then we can call the update pet function, passing through the egg and the pet as well. And now we're pretty much done with that function, so what we're going to do is just copy the name and call it right after we call the generate models function as well. Now we have pretty much one more thing left to script, and that's this frame down here as well as the total pets text label up here. So we have to update that text label, we also have to update these two text labels, and then we also need to update the progress bar as well. So what we're going to do is above our update pet function, we're going to create a brand new function called update progress. That's not going to accept any arguments, and then we're going to create a variable called collected pets. That's going to be equal to the pets config.get total collected pets, and then we're going to pass through the state manager.get data. Now that we've gotten the collected pets, we also want to get the total pets, and that's going to be equal to pets config.get total pets. Now that we've gotten the amount of pets that the player has collected and the total amount of pets, we can then do the math to figure out the percentage of this. So we're going to say local percent equals collected pets divided by the total amount of pets. And now that we've done that, we can start updating the progress bar inside of the extra frame. So we're going to say extra.progressbar.progress because that's the frame inside of the progress bar frame, and then we want to modify the size of this. And of course, we're going to use a udim2.fromScale, and for the x, we're going to say percent, and for the y, we're going to say 1. So the width of this frame is going to be based off the percent, while the height is still just going to stay 1 as it always is. Then we can actually copy and paste this, and instead of adjusting the size, we're actually going to adjust the visibility of this. And now we only want to display this if the collected pets is greater than 0. The reason for that is, well, let's just look at what this looks like when the x is set to 0. When the x is set to 0, we can still see a very small, weird-looking black line there. So since that black line is there whenever this equals 0, we would rather set the visibility of this to false, so we just don't see that black line there. So that's why we're setting the visibility the way that we are. Then after that, we still have some work to do with the progress bar. Inside of the progress bar, there's actually a text label called amount, and we want to set that text label to something. Now how we're going to set the text label is by first displaying the amount of collected pets the player has right beside the total amount of pets that are in the game. And then after that, in parentheses, we actually want to display the percentage. And we actually did this before. How we did this is we're going to say math.floor, then we're going to divide the collected pets by the total pets, multiply that by 100, and then we want to add a percent symbol directly after that as well, and that's how we're going to update the amount text label. So now that we've updated the progress progress bar, there's also a text label inside of the extra frame called amount, and the text of this text label is going to be the exact same as the amount text label inside of a progress bar as well, so we can literally just copy and paste it just like that. And then after that, finally, we have a total text label, and we want to set the text of this to total pets, colon, and then inside of here, we're going to display the amount of collected pets the player has, slash, and then the total pets, just like that. And now that we've created this function, we can actually use it. And when are we going to use it? Well, we're actually going to call it right after we finish going through this for loop inside of the generate GUI function. So we're going to call the update progress function just like that. And now we're going to go in that regard. Now we have one or two things left to do on the client side, but we can begin scripting this on the server side. Before we start scripting this on the server side, we want to actually create a brand new remote event. So we're going to go inside of the replicated storage, inside the remotes folder, inside of the pets folder, and we're going to add a brand new remote event, which is going to be called index pet. Now that we've created that remote event, we're going to go inside of the server script service, and we're going to go inside of the pets module script. Inside of here, we want to go to the give pet function, and right after we actually give the pet to the player, we want to also add that pet to the player's pet index. So we're going to say profile.data.pet index, and then we want to index that with the pet.model, and we're going to set that equal to true. Now, if you're unfamiliar, pet.model, this model property is actually a string, and that basically is the original or definitive name of the actual pet. So now that we've added that pet to the player's index, we can also fire the remote off. So we're going to say remotes.indexPet, fire client, pass through the player, and pass through the pet.model as well, just like that. Now that's all that we actually have to do on the server side, and now we can add this to our state manager. So inside the replicate storage, we got the client folder. Inside of here, we have that state module script, and we're going to go all the way down to the very bottom. What we're then going to do is basically just copy and paste the last remote event that we set up. Instead of going inside of the eggs folder, we're actually going to go inside of the pets folder, and then we're going to be using the index pet remote event. The only argument that we're going to get from this is actually the pet, which is going to be a string, and then we're going to say player data pet index. We're going to index that with the specific pet, and we're going to set that equal to true, just like that. And now that we've updated the state manager, we also want to update the GUI as well. So we're going to go back inside of our pet index script. We're going to go to the very bottom of the script. We're going to go inside of the remotes. We're going to get the index pet remote event. We're going to say on client event. We're going to connect that to an anonymous function. Of course, inside of this function, we're going to accept the pet. And then inside of this function, we're going to create a variable called egg. And that's going to be equal to eggsconfig.getEgg of pet, and we're going to pass through the pet. Now that we have that egg, we're going to say task.delay, wait 0 seconds, create an anonymous function inside of here, and then we're going to basically call most of our update functions. So we're going to say update egg, pass through the egg. We're going to say update pet, pass through the egg and the pet. We're going to say update surface GUI, and then we're going to say update progress as well, just like that. So every time a brand new pet is indexed, everything is going to be updated as it should be. And now that we've done all of that, let's actually go into the starter GUI and inside of the pet index, and let's do some of the finishing touches. So inside of the container, we have this template right here, and inside of that template, we also have another template. We want to set the visibility of this to false, and then we also want to set the visibility of this template to false as well. Now that we've done that, we also want to set the enable property of the screen GUI to false as well, and now that's all good to go. Once we've done that, we can actually go into our game and start testing this out. Ugh, I made one small mistake right here. So inside of the update pet function, for the viewport frame, since we did copy and paste it from this function, that's kind of why this bug occurred. Instead of saying .egg, we actually want to index this egg with the specific pet so that we get the specific viewport frame of that pet. Turns out I made another mistake as well. I don't know how I didn't realize this. I guess I was moving pretty quickly. Of course, we're not supposed to use find first child on a remote event. We should use fire client, and then that'll fix that. So we can go over here, hatch a pet real quick. Now we see we just got the dog pet, and if we go back, look over here at our pet index, we can see that the service GUI has been updated. We've now collected 1 out of 6 pets, aka 16%. If we go ahead and open up the pet index GUI, we can actually see that the dog model is now displayed right here. We can see that the progress has been updated here as well. So all that is visibly displayed to us, and that's all working great. So the only other thing that we want to do is go inside of our pet index screen GUI, inside of the frame, inside of the container, and inside of our template frame right here, we have this egg viewport frame. We actually want to set the layout order of this to some very large negative number. Something like negative 999,000 should be good enough. And the reason that we're doing that is because our pet index screen GUI will now be displayed correctly so that the egg is on the left side of all the different pets. Anyways, ladies and gentlemen, with that being said, that's going to be it for this episode. If you guys did enjoy, as always, make sure you smash the like button, also hit the subscribe button, and turn this post notifications on so you get notified every time I upload a brand new Roblox development video. Of course, I have a Patreon if you guys like to support me and gain access to all scripts and game file that I made during this episode. There's a link down below in the description, and you guys can go and check that out. With that being said, I'll see you guys in the next episode.